In this video, we are going to give an example of Markov modeling in Excel, and as you can see, the objective is to assess the cost effectiveness of this new drug for nodding disease, and the drug reduces nodding disease mortality. We have some data here. We have the age of onset is 5 years, cycle time is 1 year, the time horizon is 25 years, the discount rate is 3%. And we have our model diagram right here. We have the well state, nodding disease, and dead. And we have other data, the nodding disease probability or incidence. We have background mortality for different ages right there. And we have the probability of recovery, which is this arrow going from nodding disease to well. And we have the mortality for nodding disease with no treatment, 20%, and with treatment, 2%. And if we go down, you will see that we have other data. We've included some utility data, utilities, outcomes. For well, it's 1. Nodding disease has a utility of 0.6, and dead has a utility of 0. The new drug costs $2,500 per cycle or per year, and other clinical care costs $2,000 per year. End of life care costs $5,000. And here we have just the transition matrix, and it shows in green the probabilities that we need to estimate. And we have these ones which are set at 0 because no one goes from the dead state. And we have this one which is an indicator for the absorbing state. Everyone who's dead remains dead. So we shall come back to the results table later at the end. But now let's look at how the Markov modeling works. So moving on, and remember we have two traces. We have a trace for no treatment and a trace for the new drug. So let's go to the trace for no treatment. We have this column B, it has the age, and this column C has the cycle in years. So we said the starting age was 5 years, and that is cycle 0. And then we have the discount factor. The discount factor is just to account for discounting. At time 0 and time 1, there's no discounting. At time 2, you discount by 3%. You get a discount factor of 0.9708. And this is the formula. The discount rate is given as a formula. Disc is the discount rate. And you can see how it goes reducing over the years by cycle. So this in pink is the Markov model, and these are the states. The states are in columns. So you have the well state, the nodding disease state, and the dead state. And this is the starting population, the cohort of 1,000. In the baseline cycle 0, you have 1,000 in the well state, 0 in the nodding disease state, and 0 in the dead state. And the sum check is 1,000. You have to keep track of the cohort. So what happens in cycle number 1? As you can see in the formula, we have the probability of those who come from well, who remain in the well state. Then we have those who join from nodding disease. And those ones are the ones who go into the next cycle in well. And for the ones who are in nodding disease, as you can see, the formula is those who get nodding disease and come in, those who remain in nodding disease. And then for the dead state, you can see that it calculates the people who die from background mortality and those who die from nodding disease, and also those who stay dead, who come from the dead state, which is in column G. And if you look at these variable names like PW to D underscore 10 and PND to D, no treatment, they come from variable names that I have created in this worksheet. In this worksheet, I have different variable names created. So for example, here at nodding disease, the variable name is PWN to D right here. So it's a variable name that I've created that Excel can follow into the trace. But if you follow all the formulas, then you can see that, and after that, the formula remains the same for the entire column. And you can do it for the entire cycle time. And I've modeled a cycle time of 30, although I said 25. And so once you have this engine running, this is called the Markov trace. Once you have that engine running, then you can now enter the life years and qualies. So for example, for life years, you just need to follow the survival and add the survival down the column. So here you have 1 year, 1 life year lived, and remember this is discounted because we are multiplying by the D column, the discount factor. So it's just, and remember we are dividing by 1,000 because we are modeling 1,000 people, but we want the mean life years and the mean qualies and the mean costs. So same thing for qualies, we are adjusting for the utility, and you can see these variable names come from the main sheet, and this is the utility for well and the utility for nodding disease, and it just carries over the same down. It just changes in some of the cells, and it's the same thing you do for cost. You add the different costs, so you have the costs of care. This is the no treatment trace, so it only has costs of care, regular care, and costs of end of life care, but doesn't have costs of the new drug. And you can see that it continues accruing costs up to the end. Now, at the end of your cycle time, then you have to sum the outcomes, the payoffs multiplied by the probability of being in each state. So for here, the life years, it's the sum, as you can see, it's the sum of all that column, the whole of that column. And also the qualies, it's the sum of the entire column there. You can see it's the sum of the whole column, same as cost. You can see it's the sum of the whole column. So this is the Markov trace for no treatment. And for new drug, the only thing that changes is the probability of death, which is this one, P, nodding disease to death for the new drug. That's the only thing that changes. And it means that survival is going to be higher for the new drug. And if you look down here at survival, but we should probably make these into 2 decimals, so you can see that they're not zeros, they're actually fractions. Make them 2 decimals. You can see that it's building up survival, and the survival is higher. The survival here is higher, and the qualies are higher for the new drug. Qualies are higher for the new drug, but the costs are higher as well. And if you look in the cost, for the cost formula, you will see it has end of life care, cost of end of life care, cost of regular care. Then it has cost of the new drug here. So it has cost of the new drug there. So now once you have these models running, then I usually like to put my results on the main sheet, and I pulled all those estimates. I pulled all those estimates from these sheets. As you can see, it's pulling from the M-trace no treatment. It's pulling the life years, it's pulling the costs, pulling the life years from the M-trace no treatment right here, and it's pulling also the qualies. So you can calculate the incremental cost. This one is pulling for the new drug trace from this sheet. So you can do the incremental cost and do the incremental life years and the incremental qualies, and then calculate the cost per life year saved here in yellow, and the cost per quality saved. So the conclusion would be that this drug is cost effective, depending on the country, but in most countries this would be cost effective by maybe one of the methods like a threshold or like a league table. I think it wouldn't be a bad drug. But remember, this is a completely hypothetical example, but I hope it gives you a flavor of how you can do the computation of a Markov model in Excel.